Good evening, everybody. Welcome to another episode of our Space Engineers Let's Play. This is episode 33. We're in version 1.190.1 still, playing survival. And last episode we got our oxygen status script up and running. This episode is going to be pure scripting, so if you're not interested in that, I'm very sorry about that. But that's what we're going to be doing. I spent a little bit of time between episodes, both rearranging our inventory just to get everything into the large cargo container, get the rest of our cobalt refining. Uranium is ongoing. We've got a decent amount in the industrial complex reactor, decent amount in the colonizers reactors. So I'm really not worried about that for the time being. That's a lot more uranium than we've ever had available to us up to this point, so that's cool. But today we are going to be working on, like I said, the script, specifically focused on power status. Also between episodes, I did a couple of updates to the code where we left off last time. We are now setting a default font color of our panels to dark slate gray. Using the panel.font color equals color.dark slate gray. There are a bunch of different options here. Those are all on the API link that I posted in the description to last episode. I will also post it in the description of this episode. We also did some refactoring here in our main method so that we weren't calling all of the oxygen display status stuff within the main method. This is now being called as a separate function. So all this function is doing is pretty much the exact same thing as it was doing before, except I did collapse these two print panels calls into one call. So we're just calling oxygen status, putting a new line, then putting the string that we construct right here. You'll notice here I got this update source thing. This is something that I noticed in Sam's Autopilot Manager, which is an incredible script, by the way. So if you ever get a chance to take a look at that, there's some awesome tutorials and demonstrations and whatnot on YouTube. It's very cool. Probably going to try to copy a bunch of it. I'm probably not going to just use it, because what's the fun in using somebody else's code when you can customize it to do exactly what you want it to do? So I'm probably going to customize a lot of stuff and do something similar, but not exactly not exactly what he did, excuse me. But again, it's very impressive. But one of the things that I saw is when he's in his main method, he is doing things both on the 10 tick update and the 100 tick update, and we only want to do the oxygen display update on the 100 tick update. We're only running on the 100 tick update now because of the way we have our runtime frequency set here. But at some point we may want to change that, and we will still only want this display of the oxygen status to happen on the 100 tick updates. There will also be instances where this is being called because we explicitly ran it from the terminal or from the hotbar or whatever with an argument, and we won't want to necessarily update on that either. Now this is a pretty quick function, so we don't really have to worry about it lagging or anything. An extra update's not going to hurt anything, but just for the sake of, for one, trying this method out, and for two, being able to kind of separate that and make sure it only happens when we really need it to happen. I went ahead and put that in there, and I think that's pretty cool. So kudos to him for setting that up and inspiring me to copy it. So yeah, on that note, let's get started. We're going to put this on panel 2 over here. But first we need to create a list of IMI text surface objects. This is going to be the power status panels. There's a new list of IMI text surface objects. And then we need to instantiate that. And I think I'm going to, how do I want to punch this together? I mean, it doesn't really matter. But in terms of making the code look neat and clean and stuff, I'm going to get all the panels, then configure all the panels. So that's the order I'm going to do things in. And that's what I think will look the best. So power status panels dot add main cockpit get surface. That's number 2. and then configure panels, power status panels. All right, so that should have the panel over here labeled number 2. It's the top right panel, I think it's called in the terminal, but it's number 2. That'll retrieve it, store it into the list. So if we want to have other power status panels, just based on being LCD panels or different cockpits or whatever, in the future, even if it's not necessarily on this colonizer, but just if we're reusing the script, we'll be able to do that. Incidentally, also between episodes, I posted the script as it existed at the beginning of this episode on GitHub. I will put the link to my GitHub in the description of this episode as well. And I will be updating that as we go along. I'm going to also try to get hold of my other scripts. I'm going to have to do some moving around. No, I'm not going to have to do that much moving around. It's all in my, because I don't have the script on the mine construction module, or mine construction rover rather, down on the Earth-like planet in this save. That's all in my creative save. But I'll pull that, and I'll also get the borehole drill scripts as well. And so those will both be available on GitHub. But anyway, getting back to what we're doing now, we're going to create a new function called display. No, it's not cockpit oxygen. Display power. And how do we want to do that? I think we need to pass in the grid terminal system. You will notice also that I made this static, and I'm going to do the same thing here because this is really just grunt work. We don't need it to be part of the instance of this program class. It can be kind of a standalone piece of code, and I'm going to do that here as well. I'm pretty sure that's okay. The downside of doing that is we have to actually pass in the main cockpit here, which we have retrieved up here, so it's fine. But for the grid terminal system, that is an instance variable of the program, so we have to pass it into a static method if we want to use it. It's not available until you are actually inside the running instance of the... actually, you know what? I don't think we are going to end up passing that. No, we're not going to end up passing that because we're going to get all the bits beforehand, I think. Maybe. In the cockpit, in the constructor. See, I had this conversation a little bit with Patrick Henson, who is also doing a scripting tutorial series right now, about the difference between instantiating your variables, or initializing your variables rather, in the constructor versus initializing your variables in the main method. The advantage to doing it in the main method is they're up to date. So like if something gets destroyed or if you change something, it will get updated automatically because it's running inside of main. On the other hand, that means it's also going to run every time you come through the script, and that may be a little bit superfluous. So what I want to do, I think, is I'm just going to do it in the constructor for now. List my power producer. So this is going to be our list. It's going to hold all of the power producers. That's going to be batteries. That's going to be hydrogen engines. That's going to be reactors. It would also include solar panels and wind turbines if there were any. There's obviously not going to be any wind turbines on a small grid ship, but in the future, if we run this script, on the station down on the Earth-like planet, for example, it will also be able to pick up the wind turbines in the as my power producer. So that is all going to go in here. And then we're going to instantiate it, or initialize it rather, down here. That is with grid terminal system. Now up here we did get block with name because there was only one and we know what the name is. Down here, we have to use a different method. We have to use grid terminal system, and we can save it out directly because it just returns the block. In this one, we actually need to pass it in the list that it's going to save everything to. So we're going to do grid terminal system.get blocks of type my power producer. This is a templated function, meaning that the type of list that you pass into it is dependent, or that it is required to be passed into it is dependent on what you put here in the angle brackets. So since we've got those in the angle brackets, we can do power producers. Now, we also want to constrain it because we don't really want the reactors on like the industrial complex, for example, at least not by default. I'm actually going to make that dependent on an argument and a status flag that we can change. So if include connected is true, we're going to include all of the connected grids. If it's false, we're only going to include the actual grid that we've got the programming block on. Now, that the way that we're going to code this up, it will include subgrids like things that are attached to rotors and pistons, but it won't include things on the other side of a connector. It will also include anything that's connected through a merge block, because that's not even a subgrid at that point, like it would be through a rotor or a piston. That's going to be actually part of the grid that the other merge block is attached to. But so if anything is attached to a merge block, it won't get filtered out by our filter function we're about to write. But if it's on the other side of a connector, like the industrial complex is now, it will be. So we do that with a filter function here, and that is going to be like this. This creates a function passing this in as the variable, and what it does is it passes in each one of these my power producer objects that it finds, passes it in here, and then runs it through this function. If the function returns true, it adds it to the list. If the function returns false, it doesn't. So we're going to say, return, because it has to return a Boolean value. It's going to return include connected, or, so if include connected is true, it's going to return it regardless. If include connected is false, it's then going to check this, which is going to be producer dot is same construct as me. And me is a instance variable on the program that refers to the programming block. And then we will close out our function. I think that's right. I misspelled get surface, super duper, and I didn't create the function yet, so that's all fine. Get surface. Yep, display power does not exist. So I'm down here, I'm calling the display power function, but I don't have a display power function. So if I do static void display power my terminal system GTS list my text surface panels. I'm not going to have that do anything just yet. I just want to make sure I can clear the error. My terminal system is not what it's called. My grid terminal system. Yeah, that's what it's called. Okay. I remember the names of things. Okay. We've got this getting all of the power producers. I think that means we don't actually have to pass in the grid terminal system. We just pass in the power producers list and the panels. But we've got a variable to store that. We've got a flag for including connected grids or not. We're defaulting it to false, so we'll worry about that later. Probably in another episode before we get around to screwing with that stuff. I'm just trying to get it up and running for now. Specifically today, we're probably mostly going to focus on the hydrogen engines because there's a little bit of shenanigery that goes involved in that, because the hydrogen engines themselves do not actually have their own API yet. They're a relatively new block, and the API is not available on the website that I have in the description. So I don't know if it has one, if it has an interface type, or if it's just not there at all. But because of the complexity that goes into that, it's a little bit tricky to actually filter it out. So instead of passing in the grid terminal system, now we're going to pass in power producers. And instead of taking an iMyGrid terminal system here, we are going to take a list of iMyPower producers called power producers. No, it's not actually power producers, it's power producer. Yeah. Okay, so now that's right. Now, what we're going to do first, because I don't remember exactly how to do this, is we're going to just loop through all of the power producers. And echo producer dot block definition dot type, I think is what the variables are called. I'll find out how wrong I am now. It's not contain a definition for type. Yeah. Oh, and echo's not a part of the thing. Just print panels. So what this is doing is actually needs to be false. This is going to clear the panel over here, so that'll help us verify that we've set that up correctly to start with. And then it's going to print the type, at least when I do it correctly. Is it type ID? Okay, cool. Yeah, that's what it is. I just need to convert it to a string. Dot to string. There we go. So this is going to clear the panel that we've selected over here, the top right panel, the one that we're eventually going to display all this stuff on, and it's going to loop through all of the power producers that we saved in our list, meaning the ones that are actually connected to the main grid or are part of the same grid as the programmable block, not connected to, but part of the same grid, and it's going to just print their block definitions type ID. So that's where the variable is stored that's eventually going to be able to tell us hydrogen engine. And they're all on the same line, so I can't actually read them. So this needs to be an interpolated string. Oops, I need to put the curly braces in. And then I need a new line character. There we go. Okay. So object builder is not helpful. But then hydrogen engine looks like is what it's called. So what we need to do now is, first of all, this is going to be the hydrogen engine section. Instead of print panels, what we're going to do is we're going to say if, get rid of this, if producer dot block definition dot type ID dot to string dot index of hydrogen engine does not equal -1. So the way index of works is it returns -1 if it's not in there. Forgot to close a parenthesis there. That would have been a problem. So if the hydrogen engine is not -1, it means it is part of the the type ID, so it is in there. And if that is the case, we want to print panels, interpolate a string with producer dot block definition dot type ID dot to string dot split on the underscore character, because you see it says my object builder underscore something or other. I want to split that apart on that underscore and then display the second part of it, which is index 1. And then new line character. Meteor storm inbound. I'm just going to assume I'm safe. And then we need to close the blocks because we initially were just doing this all in one line, but now that we have an opening brace, we need a closing brace, and the same for the if statement, because we're going to do a little bit more complicated stuff in here. So I'm doing it all in one line is a bad idea. Cool, didn't break it. 2 hydrogen engines, perfect, that's what we're expecting. Okay, so next thing we need to do is we're not actually interested in the type ID anymore. Since we got it here, we found the hydrogen engines. That's what we're looking for, is the hydrogen engines. We don't need the rest of this now. We don't need this anymore. That's not what we're actually here to do. Is we're not here to display the block definition type ID. That's not the point of the exercise here. What we actually want is bits from the detailed info. Like that, which you'll notice is the exact same thing that we have here. What we actually want is we need to split this by the new line character, so we'll get each line separately, and we want the bottom line because we've got the type, we know the type. That's not interesting. Max output and current output are both part of the iMyPowerProducer interface, so we can get those directly. But the amount of hydrogen that is actually inside of the hydrogen engine, that's not something that we can get. For the hydrogen tank, there's a iMyGasTank interface, so we can use that. Where is the tank? Right here. We can use that to figure out what the capacity is and then the ratio filled, the same as we did for the oxygen. Like, it works the same way, the same variables are available. So we can do that for the tank, and that's fine. But we can't do that for the engine because it's a power producer. It's not, at least I don't think, it also implements the gas interface. So we can't use that to get that. We have to pull it out of the detailed info. But that's not a big deal. We can do it. It's just a little bit of fancy coding. At least I'm going to call it fancy so it makes me sound cooler. But anyway, so we need the 4th line here. So if we split on the new line, we need index 3. Because remember, these are 0 index systems. So detailed info dot split on the new line character index 3. There we go. So now we've just got the fuel lines for each hydrogen engine. Now we want to split it on space, on a space character, because the first space gets us there, second space gets us there, then we're going to need index 2, the 3rd item, which is the fuel tank capacity. So go back in, edit, dot split again. Space is the default character, by the way, so that's why I'm not putting it in there when I split on space, because I don't need to. But then we need index 2. There you see, now we're just getting the bit at the very end in the parentheses, the 1600 liters out of 1600 liters. Now we need to split that apart. And I'm going to have trouble remembering the C# substring functions here. But in any case, we actually do want to save this because we're going to do some manipulations to this once we've got it. So now we're going to do a string array. Fuel capacity. not just fuel, because it's going to be the amount of fuel and the capacity. So string array called fuel that is just going to be producer dot detailed info dot split, basically the exact same stuff that we've got below here, because we were just echoing it out or displaying it on the panel before. Now we're actually trying to save it, so we're just doing the same thing. Split index 2. Now this is just a string though, so in order to get a string array, we need to take the next step, which is to split that on the slash character that separates the total amount in there from the total capacity. So now if we change this to, instead of displaying all that, just to display, oops, fuel sub 0, this is going to just be the open parentheses 16,000 L, and then it's going to stop. There we go. So now we need to get rid of the parenthesis and the L, and this is where I'm going to have trouble remembering how to do it. So for fuel sub 0, that's going to equal fuel sub 0 dot substring 1 comma fuel sub 0 dot length minus 1. I think that's what we need. So what that's doing is it's pulling a substring of fuel sub 0, starting at the first character, going the length, and then minus 1. And I actually need to minus 2 because we're going 1 in to start with. So the length is all, how many is that? 7 characters? I guess it's 7 characters, however long it is. But then when we do substring starting at 1, it cuts off the parenthesis, but it still thinks the length is 7 characters because we haven't saved it yet. So we actually need to minus 2. Because this actually is telling it the length of the substring, not the end character index. So it's the length, and we don't want it to get the L, so we need to come back. We need to back off 2, 1 for the parenthesis, 1 for the L. So I think that's right. We'll try it. I got the function name correct. That's a start. Perfect. Now what we actually want to do with that, though, is create a float called fuel amount equals fuel sub 0. No, not fuel sub 0 equals, oh crap, what is it? Parse float. No, that's not what it's called. Float.parse. No. All right, hold on one second. I'll look this up. I usually work in JavaScript, by the way. I'm not sure if I've mentioned that. But because I usually work in JavaScript, I forget little details like exactly how the hell I'm supposed to do this in C#. Parse float. Convert string to float in C#. Oh, thank you, Stack Overflow. You are a god. Okay, so there's no capital F, I think. Yeah, okay. I was actually looking at the question, not the answer, but the question is talking about some super duper long decimal point thing, and this isn't that complicated. So we can do just parse. We don't need to pass any fancy arguments and trim it down or whatever. But yeah, there we go. I guess that doesn't have a separate data type there. That's not going to change because I didn't do anything. I didn't do anything with this fuel amount. So that's fuel amount. Now we also need fuel sub 1 to be fuel sub 1 dot substring. Now this one we need to start at 0 because there's nothing at the beginning, but we still need to do fuel sub 1 dot length minus 2, because there's an L and a parenthesis at the end of this. But I'm going to change this to display sub 1 just so we can make sure we actually got it right before I continue. Now this shouldn't change because it's 16,000 out of 16,000, so it's full, so it shouldn't change anything. And it also shouldn't throw me any nasty exceptions, and it didn't. Cool. So that's right. So now float fuel capacity is float dot parse fuel 1. So what we're doing here is we're converting this into a float so we can do math on it, because you can't do math on a string. If you try to do, 16,000 divided by 16,000, but both 16,000s are strings, it's going to get super duper confused and be like, hey, what the hell are you talking about? That doesn't make any sense. That's not a thing. Go away. For example, if I do fuel 0 divided by fuel 1, now this is just going to do the operation. It's not going to try to save it to anything, but it's not going to work anyway. Operator divide cannot be applied to operands of type string and string. That's not a thing. You can't do that. Only assignment, call, increment, decrement, new object. It's telling me I can't do that as a statement anyway. JavaScript wouldn't care. JavaScript doesn't care about anything. JavaScript's like, oh, you want to do this crazy thing? Fine, go ahead, have fun with that. But if we do, on the other hand, float dot fuel ratio equals fuel amount divided by fuel capacity, that it has no problem with. It's like, oh, okay, cool, I can do that. So what we want to do now is we actually want to come out of our loop because we're going to total all this up. We don't want to necessarily do each engine individually for the status, for the summary anyway. And because this is the summary, I actually want to change this to display power summary, because we're going to do a detailed view that will actually tell you how much fuel is in each engine rather than in one engine. But that's for a future date. That's going to be what we use this main center display for. But yeah, that's coming much later, because we're going to do all sorts of crazy stuff with arguments so that we can actually use the controls on the hotbar to, basically use this as a terminal we can push buttons on and do stuff, and it'll be pretty cool. That's something else that I saw them doing in the SAM autopilot manager that I thought was awesome. So I'm going to try to replicate that in some way. So anyway, what we're doing here is we're going to start totaling this up, and the way we do that is we do float total fuel amount equals 0, and we put the little f at the end just to signify that this is a float. I don't think we necessarily need that because it'll cast it automatically from an integer, but it's something that you usually do and something that I'm going to continue to do just because it helps to signify when you're trying to read it that, hey, this is a float, don't forget. Total fuel capacity equals 0f. So what we're going to do here is we are going to get our fuel amount, get our fuel capacity, and we actually don't need to do this yet because we're going to get it for everything. And you know what, actually I am going to leave that in there just because we may use it later, and make some changes to this function so that it's actually saving this out, and when we do the detailed view we can use this information. Actually that does make sense. Basically have a hydrogen engine stats kind of structure and save all this out to that and do this in a separate method. But that, again, that's going to all come later. We're not going to worry about that right now. We're just trying to get it running because I am definitely starting to run long here and I don't want to run forever. So we're really just going to be doing the fuel for the hydrogen engines, and depending on how quick I can get it to work, maybe the power output. Yeah, I'm going to do the power output too. I'm going to go ahead and start working on that. Float total max power 0. Float total current power equals 0. Anyway, so what we actually want to do here is we want to do total fuel amount plus equals, which adds it to the current value, which is currently 0, plus equals fuel amount total fuel capacity plus equals fuel capacity. And I'm going to break this up some for readability purposes. Then total max power plus equals, going back to the producer now because we're done with the string manipulation of the detailed info, equals producer plus max power output, I think is what the variable's called. And then total current power plus equals producer dot current power output. And these are both attributes of the IMyPowerProducer interface. Does not contain max power output. That's not what it's called. Nor is it called current power output. Is it just called max power and current power? No. And no. All right, look it up. It is called current output and max output. I deleted the wrong part. Max output and current output. That makes sense actually because the battery also has an input. Compilation successful. All right, cool. And we don't want to actually display anything here. We want to wait until the end of the loop. And now that we're done with the loop, so this is doing the information for each engine. So in this section, we're getting the fuel. In this section, we're getting the actual power. And the current output for both of them is going to be 0 for the time being because they're actually turned off right now. But then what we want to do after the loop is we want to do print panels to panels, an interpolated string that says power summary. And I'm actually going to come up here and get rid of this line because it's superfluous, because we're going to do that down here now. Because this is going to be a fairly long function when it's all said and done. We're going to end up breaking it up, but we're just doing the hydrogen engines now. So we'll do power summary, new line. I didn't actually need to interpolate that, but false, so we'll clear it here. And then we will do, actually, you know what, I'm going to put this up at the top. I just deleted it. I'm going to put it back, except I'm actually put something in it now. So we're going to print power summary up here at the beginning. And then down here, we're going to do print panels again to panels. This time it actually does need to be an interpolated string. And we're going to do, no, it doesn't actually, not yet. Hydrogen engines. You know what, I'm going to count these. No F on this one because this is an integer. No floating point values. So we're looping through all the power producers. If we find a hydrogen engine, count plus. That's increment that adds 1. You don't have to do plus equals 1. You can just do plus plus. There's also minus minus. If you do it afterwards, it does it after it processes this. So if you were saving this off to a variable, it would just save hydrogen engine count before you incremented it, and then it would increment it afterwards. If you put the plus plus at the beginning, it increments it first, then saves it. So it makes a difference. It doesn't in our particular case, so it just looks neater to do it at the end. And for that reason, because we did that, we do want to do interpolation here. Hydrogen engines, hydrogen engine count, new line. But we do not want it to clear the screen this time. So then we want to print panels max is total max power. Current is total current power. Then print panels total fuel is total fuel amount. Liters. This is probably going to end up being longer than I want it to be to fit on the screen, but we'll deal with that when we actually are starting to add more stuff to it. Total fuel amount liters. New line. Print panels. Total capacity. Total fuel capacity. Liters. New line. Print panels. And here we're going to do total. I want this in parentheses because we're going to do something to it. Total fuel amount divided by, actually need it in double parentheses, it's going to do a lot of stuff to it. Total fuel amount divided by total fuel capacity times 100 dot to string n2%. New line. I think that should be it. Power summary, hydrogen engines 2, max 1, this in megawatts, I need to put units on there. Let me go ahead and close this so we can see what we're doing. And that is too big. So power summary, hydrogen engines 2, because there's 2 engines, max 1, current 0, total fuel 32,000, total capacity 32,000, and then right below that it actually says 100%, but it's cut off. You can actually see it. No, we can't see it. Can we see it? I think we can see it. Yeah, we can see it because we go to cockpit, then we go to top right screen, then we go to edit text, and it displays all of it there. Because this is being set. I mean, we could mess with this, but then the program would update it and change it anyway. So there we go. Hydrogen engines 2, max 1 megawatt, current 0 megawatts, total fuel 32,000 liters, total capacity 32,000 liters, 100% full. So now I just need to figure out how I want to rearrange that so it actually fits on the screen neatly and what I want to leave out. Yeah, I don't know. But that's for another time. I'll think about it. I'll figure it out. I'll fix it. And I'll let you know what I decide on next episode. And I will update the code on GitHub. Please subscribe if you're interested to see what happens next. In the next episode, we're going to continue with the power stuff. The rest of it should be relatively easy. The reactors and the batteries are much more straightforward because all the information that we want is actually available through the API. We don't have to parse through the detailed info to find it, do all that string nonsense. So that will be simpler. We'll be able to do both of them as well as the total readout. But I'm gonna have to figure out how I want to arrange this because that screen's way too small to do that way without making the text smaller. There's only so much smaller you can make the text before you can't even read it. So I don't know. I'll figure out what I'm gonna do, and we'll figure it out next episode. We'll do it next episode. I'm far enough ahead on recording at this point that I've got a couple of days to work on it and sort it out before I'm gonna run behind. So if it takes a while to work out, then so be it. But as I said, subscribe if you want to see what happens. Likes, comments, and verbal abuse are welcome. Anything you want to see, please absolutely let me know in the comments. I am more than happy to be accommodating. If you're super duper bored of scripting and you want me to do something else entirely, let me know that too, and I will. Actually, you know what? I think I'll try to think of something else to do for the actual next episode, just to kind of break up the scripting stuff in case people are getting bored of that. Um, but I am going to continue with the scripting. If the response is awful, if I get a bunch of comments saying I don't want to see the scripting, I'll, you know, break that out into the separate playlist I've got going now for scripting tutorials, and not bother uploading it as part of the Let's Play. Um, but yeah, by all means, let me know, and we will see you next time. I'll figure out what I'm going to do for the next episode. I'm not sure. Maybe we'll go shoot something. It's always an option. Alternatively, we could just do some kind of cosmetic work on the ship, because now that I think this is mostly done the way it is now, the way it's designed with the turrets and everything. So I may um, put some armor blocks on here because we're, off the ground and we've got plenty of thrust, and I'm a little bit less worried about weight now, but I'm starting to worry about how nasty this thing looks. And if we're going to take it into combat at all, which I don't think I'm going to do just because this is my survival kit, this is a little bit important. So maybe I'll do that. Maybe I'll mess with the industrial complex a little bit more. I do want to put another cargo container on here, another connector on here, another reactor on here, and maybe build a floor. There's an idea. Um, Start turning this into a proper sort of station slash ship slash thing. Alternatively, we could work on the mobile construction module and start turning that into a ship. But either way, like I said, we'll figure it out. We'll do something. I am going to break up the scripting, so we'll wait at least one more episode before I continue with that. But again, thank you so much for watching. I appreciate it. Subscribe, like, comment, verbal abuse, all that good stuff. Again,